Greetings to all the viewers. This topic is all about understanding the metaphor physics within the nanofluids. This is the part 1 of my presentation, and I am Dr. Sushil Jayakrishnan, postdoctoral research fellow in the Department of Mechanical and Aeronautical Engineering at the University of Pretoria, Hatfield campus, South Africa. So what are we going to demystify in these topics? We'll be understanding what and why we need to conserve the energy and how to sustain them, with specific applications on thermal engineering. What are the areas that needs attention on conservation of energy and sustaining it? How the advanced heat transfer fluids will act as property enhancers in conserving such energy, and what are the complexities while we prepare and synthesize such fluids. So, what do we mean by energy conservation? It is actually the effort that is made in order to reduce the energy consumption by using less of an energy service. This could be achieved either by using the energy efficiently or by reducing the amount of service being used. Let's take an example now. Let us imagine that we'll have to travel for a kilometer. If you use a car, then you are trying to consume energy. But if you are trying to take a walk, you are consuming time. In this competitive market, we cannot actually waste our time. We need to identify the means and methodologies by which we can conserve the energy, however, in a sustainable manner. So how are we going to sustain the energy? But before sustaining the energy, let us define what is energy sustainability. It meets the needs of the present without compromising the ability of future generations to meet their own needs. What does that actually mean? It means that when you want to take some resources, see to that something is left over for the future generations, so that it is not depleted in the current scenario, so that our future generations do not have anything for them to use for their survival. We need to sustain energy in that fashion. So what should be the role and responsibility as a physicist, as an engineer or a scientist or a researcher? We must convey to our rising engineers that the available energy must be conserved by using the maximum possible outcome from the minimal resources, and by sustaining them without making any changes to their current availability or current existence. We must also make them well aware of the green energy concepts that is emerging now, such as fuel cells, carbon capture, desalination processes, etc., for the next gen power source, to avoid further depletion of conventional fossils that we are currently using for daily uses. Besides, we must also make them realize that most components need effective thermal transport in order to avail maximum energy by making them function till the dead state. So, let us look at few energy costing applications. While manufacturing components, it needs the cutting tool to have good contact with the workpiece for material removal. If it happens, then the amount of electricity consumed would be very less, isn't it? To achieve them, we need nanocoolants. In order to raise the computing speed, the microchips and processors must work much efficiently, and to do so, they release more heat, which must be cooled down very effectively. So what else? We need a nanocoolant there in the forms of heat pipes. In order to improvise the brake output or performance of an automotive, it must run at lower fuel consumption. To do so, the engine must be cooled spontaneously. Hence, the radiator must run with an efficient nanocoolant. To produce more potable water through desalination, the solar stills must be capable of rapid evaporation of saline water. Again, efficient nanofluids must be circulated within. The photovoltaic cell produces more electricity if they are promptly cooled, and this could be done by circulating efficient heat transfer fluids. But isn't it a universal rule that nothing comes out as part of sacrifice and compromise? Let us see what needs to be compromised and how they could be curtailed. So, here the picture shows what is a nanofluid and hybrid nanofluid. From the image we could see that there are certain amount of particles being dispersed inside the liquid. Hybrid, as I mean, will be multiple particles inside. So as the thermal properties of conventional fluids appear to make the current energy systems to be redundant based on the needs for energy conservation and sustainability, alternate fluids were the need of the hour. So back in 1990s, Choi identified the potential of conventional fluids such as water, oil, glycols, etc. to enhance when they were dispersed with micro-sized metal or metal oxide powders. However, due to the challenges such as sedimentation, channel clogging and abrasion, the powders were downsized to nanometers and their performances were evaluated. Once the particle sizes were in nano sizes, then the fluids were coined as nanofluids. Let us see the complexities in the preparation as well as employment of these nanofluids. Preparing these nanofluids are costlier because of the time in preparation, the special ambience under which the powders are prepared or the fluid is prepared, the raw materials being used, the energy used for synthesis, and the volume of nanofluid prepared during the synthesis procedure is very less at that cost. So it's going to be the outcome to cost ratio, which is going to be very less. Even if they are prepared, they can form lumps within the fluid and can spoil the properties of nanofluids on the whole. Stability is another big challenge, where the particles once dispersed can settle at the base of the container after a certain time due to its high density. Storing them is also a challenge because of its reactivity at different conditions, and if unattended for a long time, they can environmentally be hazardous. Even if they are to be disposed, it must be processed in a parametric way. So, I think these are the open loops that needs to be sealed tight before availing the fruit of benefits. Such an intense research gap prevails for physicists and engineers like us to take up as a challenging research topic in the field of nanofluids. So, we'll meet soon in part 2 on understanding the challenges of stabilizing a nanofluid. How can we prevent them from being settled at the base of the fluid? And once it is being stabilized, the particle size inside the fluid must be one of the indicative parameters that defines its purpose at different applications. So what are the different ways of indicating such particle sizes? I hope this video presentation would have given you a broader insight of what is nanofluids, what is its role in conserving the energy and sustaining the energy, what are the various applications where it could be adopted, and what are the challenges that we are currently facing, and how far the horizon is to take up certain research topics on this to produce much innovative and advanced fluids. Your criticisms and suggestions are mostly welcome. Thank you. Stay safe. Be happy. Jai Hind.